Okay, so I'll need your help with this because I didn't go back and watch my own video. How many problems do you know which ones we did together on Thursday?
1, 3, 4.
Oh gosh, you guys are useful. Okay, so 1, 3, and 4 are done. Let's go knock out some of these practice problems and then I'll give you your next assignment. There's something I have to say that I I think I brushed past it and said it incorrectly on Thursday. I think about things like this. So when the opportunity comes, well, actually, the opportunity is here right now. Number two is a perfect opportunity. Um, what do we do first? Right. So let me tell you where I misspoke. The thing that I said on Thursday is that we don't have to worry about this. I think what I said, and maybe I'm wrong, maybe I was just imagining it, but I think what I said on Thursday was we're going to leave this one like this, and then we're going to leave this one like this, and then we're going to multiply and we're going to move the x plus 1 like that. And then I think I told you at that point that we don't have to worry about this for excluded values, but we do. Upon reflection, I realize now that we have to consider both the top and the bottom when we think about finding excluded values. And it's very easy to make a case and to want to argue about that and say, like, no, I don't think so. I think you're wrong because once we flip it to the top, then we shouldn't care anymore. But let me ask you a question. This is a really important question. I mean, you may not even know, like, you might think I'm having a stroke or something. But how many division problems do you see in problem two? There are two. There are two. Hang on a second. I gotta deal with this. This resume. Um, there are two division problems in this, and the thing I think where I misspoke last week was that I told you that once we turn it into a multiplication problem, that we should no longer care. But the thing is, this is a division problem. Do you agree? Okay. So what it means overall is that this thing that I just circled here, let me change colors. This thing I just circled in purple is not allowed to equal 0. Do you agree with that? Okay. And you would also agree, you don't have to, but I hope you do, that this thing that I'm about to circle is a division problem, correct? So hope I don't lose you on this, but at some point it'll be, if it clicks right away, that's awesome. But the thing is, the thing I just circled is another division problem. Remember, fractions are just division problems, right? And so if you approach it as the whole problem is a division problem, and that fraction is a division problem, we continue to focus on the idea that you cannot divide by 0. So here's what it means. It means the red circle cannot equal 0, because if it does, then the entire problem is dividing by 0. We also then have to say that the purple oval cannot equal 0, because if it does, then that fraction locally is in and of itself dividing by 0. Does that make sense? If it didn't make sense, here's the deal. From this point on, when we do these problems, we have to consider that we're not only going to get excluded values from the bottoms, but we're also going to get excluded values from the tops. Bottom line is this. You see that fraction? You're going to get excluded values from the top and the bottom, both. If there's any way for that fraction's top to equal 0, that's an excluded value. If there's any way for the fraction's bottom to equal 0, that's also an excluded value. Got it? So that's what I probably should have said the first time without being long-winded. But the bottom line is the entire second fraction, zeros are off limits, top or bottom. Flip, no flip. Good. Well, no, if it's division. If it's times, then just the bottom can't equal 0. Let's get to it. So anyways, back to it. So this top left is going to be x minus 2. This bottom left is going to be 10x times x plus 1, right? That's just factoring 101. And then we're going to say that that's equal to times x plus 1 over 1, like this. So you got to be good at factoring to get through this unit on rationals. All right, factoring is the key. So we can simplify and then find excluded values, or we can find excluded values and then simplify. It really doesn't matter what order we do it in. Okay. So what do you guys want to do? Do you want to reduce first and get the answer, or do you want to find the excluded, guys? Excludes while we're here? Okay, since I mean, because I had a tendency to forget that on Thursday, so it's probably a good idea. So can you see any excluded values? Two. Two's not going to cause any problems. -1 is definitely an excluded value, and you run into two issues with -1. Number one, if you put it here where I just circled in purple, you'd make a 0. And of course, if you put it here where I also just circled in purple, you would make a 0. So if you're going to make the bottom of a fraction equal 0, that's an excluded value. So we can say that x is not allowed to equal -1. But there's another one, and it's not 2. It's 0. And I'll put a green box around something that you should be interested in. That little green box right there, you see it. I know you do. Inside of that is 10 times x. And remember, you're not allowed to make the bottom of any fractions equal zeros. And if you put a 0 in place of x, it's not the thing in parentheses that I'm worried about. It's the thing in the green box. And 10 times 0 is 0, and 0 times anything is 0. So 0 would break this whole machine down. So we can say that x is not allowed to equal -1, and x is also not allowed to equal 0. Does everyone understand why 2 is just fine? Yes, I know this is a division problem, and if that x minus 2 had been in the second fraction, then I would pay attention to that. But in a division problem, it's just the second fraction we worry about, and otherwise it's just the bottoms. Okay, so we have our two excluded values. So when we get to graphing rational functions, you'll see things at -1 and 0. You'll see things happen. You'll see certain behaviors occur on the graph because of those exclusions. All right, let's get back to simplifying. So when we look at the math problem over here in the purple box, that's it all factored out. What can we do to simplify? The x plus 1s can definitely go bye-bye. Is there anything else? I don't think so. I think that's all that's left is x minus 2 over 10x. And remember, if you are tempted to cancel out those x's, you're going to go to naughty math prison, right? For like 12 years to life. So any questions on that? So we did 3, you said, and what? 4? We did 1, 3, and 4. So random. Okay, let's go down to 5. So on 5, again, here's the bottom line, is this entire fraction that I'm putting a box around, neither the top nor the bottom is allowed to equal 0. And you also cannot have any zeros in that left bottom. Okay, so in order to figure out what the zeros would be, like who the bad guys would be, we of course have to start by, factoring. So, I mean, you can copy dot flop as you factor. There's no harm in that. So we're going to leave it as 1 over what? It's perfect factoring. V minus 5 times V plus 8. And while we're here, we might as well dot flop it, right? Like why? 6. Yeah, that's what I wrote there. Can you not see the 6 there? 6. I'm sorry. My bad. Oh, is that called gaslighting if I do that? Am I using that correctly? Yes. I'm trying to figure out how to use that expression correctly. Okay.
I think that hasn't been a thing since like the 1600s.
What, gaslighting? Oh. Don't people say that? Gaslight?
My great grandma said that all the time.
Oh, so you're just calling me old? Is that what you're doing? Are you attacking me right now?
Say you're not old because you don't use the term gaslighting.
Oh,
Nobody uses it. You're just crazy.
wow, this is rad. That is, I like that. That's like next level gaslighting. Wow. I'm impressed by you guys. So here we are, and you seem to like finding excluded values early on in the process. So let's get to it. What are our excluded values? Yeah, V cannot equal -8. I agree with that. If it does, it's going to cause problems. It also can't equal +5. You don't have to write V does not equal or cannot equal every time. You can write V cannot equal and then make a list of numbers. It's up to you. That's not a big deal. Are there any other excluded values in this problem? Now that's it, right? Not much meat on this bone. So that's it. We've stated excludeds, and there's really not much canceling to do, but we have flopped it. So we're ready to cancel out our V plus 8s, and that's it. So our final answer is just 6 over V minus 5.
Do you wanna check?
Oh, thank you. I should probably fix that, shouldn't I? Thank you. Let me pause this real quick so I don't take attendance on recording. Any questions on 5? Okay, let's take a look at number 6. How many do I have on here? 10? This shouldn't take all too long. So let's factor as we go. So what's our upper left factoring going to be? Nice. And our lower left?
5x and x minus.
Perfect. And then this is a multiplication problem. And so we're not going to do any flopping this time. We're just going to leave everything as is. Remember, only flop if it's division. And I will say this because I'm long-winded and I've said it before, but I talk too much and then I lose people. Because this is a multiplication problem, if the top of the second fraction had any x's, we wouldn't pay it any mind. Do you understand that? Because we can multiply by 0, but we can't divide by 0. So when it's a multiplication, you only look at the bottom of the second fraction, not the top. Cool. So having said that, there's not much canceling to do. What can you get out of there? Now, don't everybody answer at once. Did I? So let's, oh, you want to do excluded values. That's right. You guys like that first. Okay. So sorry, what are our excluded values? Yeah, x cannot equal 0 for sure. X cannot equal 1 for sure. And x cannot equal 2 for sure. Those are all 3 things that will make zeros in bad places. Do you see how the x minus 1s cancel out? That's going to be what we come to know here in a week or so as a removable discontinuity. That's going to not be an asymptote in the graph. It's going to be a hole, something that the graph just jumps over. Whereas, do you see how we can't get rid of the 5x? And we can't cancel the x minus 2. Those are going to be vertical asymptotes. That's a little taste of the future for you. So anyways, those are my excluded values. Now let's cancel out our x minus 1. So what's our final answer? Yep. And you can totally leave these in factored form, or like Cooper was whispering, you can multiply it back out. Like you can actually put 5x squared minus 10x. My take is once I've taken the time to factor something, I'm just going to leave it factored out. I'm not going to take it apart and put it back together. Good. Okay. On to number 7 we go. So this is finally what I've been waiting for, is an opportunity to talk about this. In the meantime, let's go ahead and factor and do all of our copy.flop. What's our upper left going to say?
3 times x minus 10.
Love it. Lower left is just what it is, right? We're going to change it to times. What's our top going to be? Say it again. Good for you. So the top right is actually going to be negative, and then in parentheses, x minus 10. We talked about this in Algebra 2, and more recently, we talked about this on Thursday, that when you have a factor that's backwards, if it involves subtraction, you need to pull a negative out to cause it to flip. Okay, if it were all addition, you could just write it free for all, but minuses make things a little tricky. So you got to pull the negative to cause the switch to happen. And then that's all over 2x, right? So try to remember excluded values first. I can do this. So what are our excluded values? X cannot equal 0, and x cannot equal 10. Good. Because this is a division problem, we get excluded values not just from the bottoms, again, but from the top and bottom of the second fraction, for reasons I tried clumsily to explain about 15 minutes ago. Okay. So excluded values are done. What can we cancel out? Yep. And which ones you pick doesn't matter. You can pick any one. Well, obviously you only have one on the bottom, but either one from the top. But you can't kill them both, right? One for one. And that is the best we're going to do. The best way you can simplify an expression like this is to get the negative out. You don't generally, as a rule of thumb, want to leave negatives embedded in fractions. I told you the same thing when we did like slope in algebra 1. Like if you get a slope of -2 over +5, you just say it is -2/5. The same mentality here. So we're going to pull the negative out front. What are we going to have on top? 3 times x minus 10. And on bottom? 2x. Perfecto. And again, you want to multiply that back out. You get down with your more work than necessary doing bad self. That's fine. Okay. Pretty easy, huh? Number 8. This is not a dot flop, so we're just good to go. I'm going to leave it as 1 over x plus 7. I'm not going to flop anything. What does my upper right need to be factored down into?
-10 times x minus 1.
Perfect. I love that you can do that. So as soon as you instinctively know something is backwards and it's subtraction, pull the negative and then switch it. Good job. Good instincts there. And then my lower right is just going to stay as x minus 1. What are our excluded values? What can x not equal? Can't equal 1. And it can't equal -7. Good. As far as the simplification is concerned, again, not much excitement here. What goes? The x minus 1s. Yes, we're going to take out an x minus 1 and an x minus 1. What's our nice, clean, perfect answer going to be? Some negative pause there for effect, 10 over x plus 7. Remember, don't you put the negative on top or the bottom. You leave that to the discretion of whoever is reading your work. Okay, it can go anywhere. You pull it out as a courtesy. Still good? All right, let's do 9. 9 is, again, not a dot flopper, so we're just going to go ahead and leave it as it is. We're going to leave the 7 over the a plus 10. What does our upper right factor into?
Would be part of the 10 and
100%. A plus 10, a minus 2. And then lower right is, there's nothing to do there. This is actually a really boring problem. There's a couple of excluded values, and then beyond that, it's pretty ho-hum. Comes out nicely. Anyways, what are our excluded values? What can a not equal? A cannot equal 2, and a cannot equal -10. These are both removable discontinuities, which means that when you graph this, you will not see asymptotes at -10 and 2. You wouldn't even see it with the naked eye. This graph just has to temporarily, for an infinitely small moment in time, discontinue itself as it jumps over the holes in the graph. So again, when you can remove a discontinuity like this, like here, go ready for the red pen, kapow, kapow. I just took -10 out. Okay, it's still not allowed to be there, but it's not an asymptote. It's just a hole. And the same with the 2s, kapow, kapow. What's our final answer? 7. What a beautiful answer. And that leaves us with number 10, which is a dot flopper. So we're going to go ahead and do our thing. So we have 1 over x minus 5 times, what's the top of the second fraction going to be?
minus 5 and x.
Yeah. And the bottom? X minus 1, right? This will be an indication as to whether or not something that I've said a few times, and I don't think I've said it well yet. I don't think the words have come out the way I've wanted. Let's see if it made any sense. I'll find out now in about 20 seconds. What are the excluded values for this? So 5, x cannot equal 5. What else can x not equal? And, okay, you guys were listening. You got it. And remember, please, 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 had this, pay attention now, had the red box been the original problem, what would our excluded values be?
5.
Good. You guys are good. You listen and you understand things better than I think I explained them. So good job. Yes, you got it. So with division, we care about both. With multiplication, we just care about the bottoms. Well played. So we have triple excluded values there. Can you tell me this? I just thought I'd try. whole or asymptote, what would one be? Can we remove one as a discontinuity? Does it cancel anything? If we can't remove it, it's an asymptote. So if we graphed this like on Desmos right now, we would see an invisible line at vertical x equals 1, where the graph approaches it and comes in asymptotically. About 5, whole or asymptote? Can we remove 5? Then it's a whole. 6, nice. So if you can remove it, it's a whole. If you can't and it's stuck there, it's an asymptote. That's a different lesson, so it's okay if that doesn't make sense. So let's do our thing. Let's cancel out some stuff. I see some x minus 5s taking a dirt nap, and that's about it. What's the answer? Perfecto. So we did it. We followed directions. We stated the excluded values and we simplified the expression. And that's what we're up to today. So I'm going to leave the recording going, but of course paused, and then I'll hand out your assignment and we're going to work. And if you have questions, we're going to go over them together. And if you don't, then we're good to go. That's it. All right.